Good morning, students. In today's lecture, we will discuss an important concept in programming language called language translators. As you already know, programmers write programs using high-level programming languages such as C, Java, and Python. However, computers cannot understand these languages directly. So, computers understand only machine language, which consists of binary digits, zeros and ones. Therefore, we need a special type of system software called language translator. A language translator converts a program written in one programming language into another programming language, usually machine language, so that the computer can understand and execute it. Without language translators, programmers would have to write programs directly in binary, which would be very difficult. So, translators play an important role in programming and software development. Now, let us know the definition of language translator. A language translator is a program that translates high-level language code into machine language code that a computer can execute. For example, if I'm going to write a program in C language, it cannot understand directly by the computer. So, translator converts it into binary instructions with the help of zeros and ones, which the computer hardware can process. Why a language translator is needed? As computers operate only machine language, but humans prefer to write programs in high-level languages because they are easy to understand. Therefore, the translator acts as a bridge between human-readable code and machine-readable code. So, like the workflow is, human code is translated into machine code and then further for computer execution. Now, we will see the different types of language translators. There are three main types of language translators used in programming. So, the first one is the assembler, next compiler, and then interpreter. So, each translator works differently and is used for different types of programming languages. If you go with assembler, an assembler converts assembly language into machine code. Assembly languages uses mnemonics, which are short symbolic codes representing machine instructions. Like for example, if you want to add two numbers like A and B, you're going to give the instructions in the form of add A comma B, where add is a mnemonic. Like if I want to move between two different registers, the operation which I am going to give is move, MOV, which is a mnemonic, MOV R1, R2. Here, MOV is a mnemonic. These instructions are easier for humans compared to binary code, as you know that the binary code is only in the form of zeros and ones. The assembler performs a one-to-one translation, meaning each assembly instruction is converted directly into one machine instruction. Now, when it comes to compiler, a compiler translates an entire program written in high-level language into machine code at once. After compilation, it produces an executable file that the computer can run. Example, it's like we are going to have the language which we are going to use compilers are C, C++. The main purpose of compilation is to create an executable program. An interpreter translates and executes a program line by line. Instead of translating the whole program at once, it reads each line, converts it, and translates or executes it immediately. Because of this process, interpreters are generally slower when compared to compilers, but they are very useful during program testing and debugging. Some of the examples of interpreter languages are Python and JavaScript. So for example, if you are going to write a code in C language, it is going to translate it into machine language and it is going to produce the errors in one shot. Like it is going to compile each and every line and it is going to give all the errors at once. But the same program which you are going to write in Python, it checks with the first line. If it is correct, if the syntax and semantics are correct, it goes to the next line. So here it uses the concept of interpreter. Now we will see the advantages and disadvantages of compiler. Let us now see the advantages of compiler. It has faster program execution. Since the entire program is translated before execution, the compiled code runs very fast. It generates executable files. The compilers produce files like .exe which can run independently without the source code. Source code means like which we are going to write the code. A compiler shows all errors together. As I told you, during compilation, the compiler lists all the errors in the program at once. And this is mainly suitable for large programs. Compilers are efficient when dealing with complex and large software systems. Better security. Since only executable files are distributed, the source code remains protected. As you can see, the given example, like you can see over here, like we are writing the code in C language. It is converted into machine language with the help of a compiler. To execute the code, the executable file, to execute the code, the executable file is RAM. And then you're going to get .exe file. So here the errors are only reported only after going through the whole code. Now let us see the disadvantages of compiler. Like debugging can be difficult, as you know that the errors are shown only after the entire program is compiled. Compilation takes time. Like large programs may take larger time to compile and requires high memory usage. The compiler needs memory to store intermediate code and executable files. And it has limited error detection. Compilers mainly detect syntax errors and some semantic errors. Now, let us look at the interpreter. The advantages of interpreter are, the first thing is it is very easy to debug. As you see here, like you're having the code which is written here, it first detects the first line. If it is free from syntax and semantic errors, it will goes to the next line. So to run this code, the whole process must start over if an error is encountered. The translation stops immediately at the first line if the errors are there. If it is free from errors, it will go to the next line. Next, immediate error detection. The interpreter stops execution exactly when the error occurs. No compilation is required. The program runs directly without creating any executable file, and it is mainly suitable for the beginners as interpreted languages are easier to learn and test. And it has automatic memory management. Many interpreted languages handle memory automatically. Now, we'll have a look over the disadvantages of interpreter. Slower execution. Every time, like since the translation happens during execution, programs run slower. It has no executable file generated. Every time the program runs, the interpreter must translate it again. It requires interpreter environment. The program can run only if the interpreter is installed. Now, let us discuss about the assembler. An assembler is used to translate assembly level language into machine code. You can see here an assembler uses the processor instructions set to convert the instructions to the machine code. Like you can see, this is a mnemonic. Add is a mnemonic. You're going to add 4 and 2. It is going to generate the into machine level code. So we'll see the advantages. Like very fast execution, assembly level language programs produce highly optimized machine code. It has better hardware control. Over the hardware. So programmers can directly control hardware resources like registers and memory. It uses fewer system resources. Like as you know, the assembly programs are efficient and lightweight. Now we will see the disadvantages of assembler. It is difficult to write and understand, as assembly language is complex and requires deep technical knowledge. Machine dependent. Assembly level languages are written for specific processes and they cannot run on other machines, like they are not portable. And hard to maintain. Large assembly level languages programmers are difficult to understand and modify. It requires knowledge of low level architecture. Now we will see the difference between a compiler, interpreter and an assembler. Let us compare these three translators based on different features. With respect to input language, a compiler works with high-level language like C and C++. Interpreter works with high-level language like Python. Assembler works with an assembly-level language. Method of translation. Compiler translates the entire program at once, whereas interpreter translates one line by line. Assembler translates each instruction by instruction. When it comes to execution speed order, like assembler is greater than, speed is greater than compiler, whereas compiler is faster than interpreter. Assembler produces the fastest machine code because it is closest to hardware. Error detection. Compiler shows errors after compiling the entire program, whereas interpreter, it shows errors immediately line by line. Assembler shows the errors like if they are going to occur, they are going to occur at the instruction level. Output generation. Compiler creates an executable file with .exe. Interpreter, it has no separate executable file, whereas assembler generates machine code directly. Memory usage. Compiler requires more memory when compared to interpreter, and assembler uses minimal memory. When it comes to portability, in compiler, the source code is portable, but compile code is platform dependent, whereas interpreter, highly portable. It is highly portable, means we can run on any system, whereas assembler, it is not portable because it depends on processor architecture.